Hi everyone, welcome to season 6 of Additive Talks. If you are joining us for the first time, make yourself comfortable. Additive Talks are a series of panels that aim to discuss the use of AM in a given industry. If you've been here before, thank you for listening to our insights into the world of additive manufacturing. My name is Katie Sinze, managing editor at 3D Adept Media. And we are launching season 6 with Steve and Hauke. Steve is based in the US, Hauke is based in Germany, and I'm based in Belgium, which makes it a very, very interesting conversation for this episode. So I will give the floor first to Steve so that he can introduce himself as well as the company he represents. Hello, Steve. Good morning. Good afternoon from our side.
Yeah, good morning. Thanks for the time zone, early morning time zone for me. Good morning from California, San Diego, California. I'm Steve Fournier. I work for General Atomics Aeronautics Systems. So for those who are not familiar with our company, we are the makers of the Predator drones, the Reaper, the Sky Guardian. Historically, we've been known for our drone industry, but the General Atomics company covers multiple different other technologies. Lots of our customers are defense, Department of Defense, and our allies around the world. But more in the Department of Energy for other types of products in space and underwater. Some of the more recent development in the company outside of defense is also civilian aerospace applications, such as border patrol, fire prevention and protection, maritime surveillance to control some of the shores, and so on and so forth. So there's more than just defense application, but obviously the core of our history has been working with aerospace and defense. A bit about myself: I'm the technical director for additive and advanced manufacturing at General Atomics. My role has been, since I started here 8 years ago, to onboard additive in a production setting. So for additive manufacturing, we've been doing additive for about 15, 17 years. Like any other company, we started as a prototyping exploration and find some good values there. But we started getting too close to our products in terms of putting the parts in the aircraft. And so that transition to production was necessary. And then our leadership had this visionary move to concentrate and centralize the additive knowledge and build a team to make that transition between prototyping and production. We're going to talk about that over this panel, I think. So over to you, Aki.
Yes, well, so thanks for having us, Katie.
My pleasure.
So on my side, I'm, as you said, based in Germany, in North Germany, in Hamburg, actually, and working for Airbus, specifically for Airbus commercial aircrafts. So we are a global leader in the manufacturing of commercial aircraft, traveling around the world. But we are also manufacturing in the Airbus group helicopters, as well as products in the defense and space market. Our biggest division is the commercial aircraft, and that's where I'm mainly active, actually. But I have also had a role for the last 6 years as R&D roadmap owner, which includes actually all divisions. So R&D roadmap owner on additive manufacturing, which is obviously the topic of today. So here trying really to keep one roadmap, one vision across the divisions, harmonizing a bit what we do, promoting synergies, and driving the value that we can bring in the company. So I've been doing additive for the last 12 years in Airbus, actually. So through the initial years of hype, trying to bring this into serial production, which have been a bit bumpy, but also through the last 5-6 years where we have more and more success in serial production. And I think now really going into a phase where we will accelerate in the next years, because we're getting closer to using additive on big new products, new programs. and we will have a lot more opportunities than we had in the last years, where we mainly replaced on our running zero programs.
Thank you so much, Hauker. Well, quick reminder for the audience. Please, if you have any questions, write them in the Q&A chat. We will pause at some point during the conversations in about 20 minutes just to answer, your questions. If you have any remarks as well, you can note it down as well in the Q&A chat, and we'll be able to read them, to comment on them, and to address any concerns that you have regarding this topic. Steve and Hauke are coming from two different backgrounds, and just to help us understand the context of this conversation, I will give the floor first to Steve, because I know with General Atomics and the use of additive manufacturing, we've heard a lot about about factory of the future, Steve. That's a phrase that's consistently and widely used across this industry. And sometimes the definition of factory of the future really differs from one person to another. What makes General Atomics version unique? And what can you tell us about that?
Well, let me kind of step back and just kind of talk about what the factory of the future means to, at least to us. And
Yes.
I've been, beside additive manufacturing, I've been exploring factory of the future implication on the manufacturing technology side for a few years. And so fundamentally, factory of the future is not one single thing. It's the concept of optimizing your design all the way through quality and fielding process towards agility and efficiency. Mm-hmm. So it is not a new concept. So it's not in the future per se. It's factory of today, but yes, it's agile and efficient. And why do we want that? Well, we want that because, and the future word here means that you want to be able to be agile and efficient with whatever the future throws at you. So from Airbus, they have a product type. They have a series of products that they offer, and they optimize their factories and their process around that product. And we do the same on our side. So the factory of the future really depends on the efficiency and the integration of three things from my perspective: people, process, and technology. All so right. The nature in our field, at the very least, there's a shortage of skills. So additive manufacturing skills and then advanced manufacturing skills and so on. They're difficult to find. And so one things that we have to do, at least in our field of use, is that we need to have more coming out of our factories with a lower price point, so that we can be effective with our mission. And so what that means is that I cannot just multiply by number 3 the number of people we hire, number 3 times 3 the buildings, times 3 everything, the way we used to do that. And so what's unique about GA, or I would say a characteristic of GA, is over our 4 decades of history in manufacturing of unmanned systems and other products, we have built a vertically integrated capability. What that means is that we have design in-house, we have process optimization in-house, we have IT, and we have all these services, and then we have manufacturing in-house, a variety of different technologies in-house that is manned with people and so on. So over the years and over the decades, we obviously hired people to connect those piece of the process to make the aircraft. And then we develop our processes and we train people and we have IT systems and so on to build our process in our quote unquote factory of today, right? Where we are focusing our attention now is to say, what are the opportunities, because we don't have the luxury to start from scratch. We are, and Airbus is in the same same situation, is we have a long history. And so we have systems established, we have people, we have process. So we're not starting from scratch in a greenfield environment. So we don't have the luxury to just say, okay, the fresh starts, clean plates, and then we're bringing all the new solutions and latest technologies. We have to slowly embed this advanced technology into our process, and that means concretely is we need to seek technology, specifically additive manufacturing is one piece of it, but it's just not all of it, obviously. Processes that will be agile, so that means that I can put anything in the printer within the limits, and then I can do parts for different kind of platform, different kind of aircrafts. So we have to seek technologies like that are agile and efficient and labor efficient, because I can't afford to have 3 times the people. At the same time, there's another big aspect that is changing the way we connect the data and the digital aspects of it is AI. So AI is really helping us to connect faster with unstructured data, which was in the past a bit more difficult because we had to make the data very uniform and then connect to be able to connect it on the digital front. So there's multiple aspects of Factory of the Future, and General Atomics is moving into this this, I would say, the next generation Factory of the Future by integrating those connected systems and processes and more efficient process. Over to you.
Thank you, Steve. Well, just as a quick reminder, if we want to be able to, give the floor to the audience as well, maybe we may want to answer the questions a bit briefly. Sorry about that. So well, next question is for you, Hauke. Your role spans different departments of Airbus, and I'm truly impressed, by that, because AM may be used across different departments, but yet there are a lot of challenges out there, for each of these departments. So I wanted to understand, where does the real friction lie? Inside the organization, in the supply chain, or maybe at the regulatory level. Can you please tell us more about it?
Yeah, it might be no surprise that I would say it's probably a combination of the 3, right? And
yes,
it aligns a bit to something that I often explain. We need all 3. So if we start with, and we have challenges with all 3, but if I start with regulation and qualification, or with the regulation environment. So for Airbus, this is a big topic, right? Safety comes always first. So we need regulation for a good reason. But it's our responsibility to ensure the qualification and the robust way the new technologies like additive manufacturing work. But for sure, that is also a hurdle. But it's one reason why we have internal capabilities, internal AM capabilities. And this maybe is a good transition to the inside. So we have challenges of AM inside Airbus with these internal capabilities, but this is very important to us. We need internal capabilities to be able to design for additive manufacturing. Why? Because we all understand as AM specialists that the biggest value of the technology is when you develop better products, when you do more integrated or more lightweight products, less assembly, for example, right? And we need internal capabilities to master this technology and be able to capture the full value of it. But then, and this is the third part that you said, the supply chain. Airbus core is design and assembly of aircraft. Elementary parts, on the other hand, typically we source them. So in the end of the day, we have internal AM capabilities, but the majority of the parts, we still want to source them externally. And here, we need to be able to drive the supply chain, to drive the innovation as well. But then distributing AM over so many places, so inside Airbus and external, limits a little bit, spreads a bit the volume that we have of business, especially this initial volume where we're still trying to ramp up the technology, where we're not using it yet on new products. And this is a challenge then to reach the right economies of scale and keep track also with the technological evolution that keeps happening, right? We're doing production of flying serial parts now for 10 to 12 years since
Yes.
2015, 16 in Airbus. So we don't really have a long history yet. And the kind of machines that we have today on the market have nothing to do with the ones that we bought in 2015 to start with, actually.
Yeah, understood. Well, quick reminder, you can start, asking your questions in the Q&A chat, and then we'll pause in 20 minutes to start answering them. So next question is for both of you. Aircraft on ground situations represent some of the most acute supply chain failures in aerospace. Where does distributed additive manufacturing currently stand as a practical response, and what is still missing before it can be deployed at scale with confidence? And I feel like I will give the floor first to Steve for the defense and aerospace standpoint on it.
Well, lots of people associate additive manufacturing to distributed manufacturing to sustainment and aircraft down type of moments, thinking that additive will come and save the day. The reality is additive is just another tool in the toolbox. So we now need to talk about sustainment and logistics plan. So for my company, we produce aircrafts, and we have a number of parts that can be serviced by having part availability in the depots and inventories around the world. So you have distributed logistics, and then you have distributed manufacturing, right? So the question of manufacturing, you can say, well, if I have my parts that are available, I don't really need to manufacture anything local. I can distribute that. In times of contested logistics, for example, if let's say I cannot access my parts, can I manufacture them locally? And now you have to get into a question is, what are your manufacturing capability locally? It's not enough to have a printer. A printer doesn't do anything for you if you don't have the right material, the right process, the right people, the right conditions, the right quality systems, and so on and so forth. So you really have to look at manufacturing capability infrastructure locally. That could mean my company has a local, like it's a worldwide distribution of manufacturing capability in Europe, in India, in Japan, and so on and so forth, right? The defense industry has that called organic industrial base, which does that for the defense industry. So the goal is to see, well, can I get my parts faster because I have them made locally? But it's not just having a printer in the back of a Humvee. It's having a whole manufacturing process flow covered under a local manufacturing, contract manufacturing, or a locally owned. So practically speaking, additive manufacturing is not changing this model. This has been existing forever. And if you are a product owner like us, we have to think about sustainment as part of our offering, and we build an infrastructure accordingly. I'll stop here just to give enough time to Aki to
All right. So, okay, what are your thoughts on that? I feel like maybe you have a different standpoint.
Actually, not. I share a lot of what Steve said, and first of all, I agree that a 3D printer and additive manufacturing machine is nearly never the one solution that fits at all, right? It's one tool in your toolbox, and there are some parts that can be additively manufactured, but many others not, and you still need infrastructure for that. But even if we say, like, okay, we assume we can print the parts, then it's never really only the 3D printer that you need. Same again, as Steve actually said, you also need to qualify the people in the whole shop that you operate, right? And so you need to differentiate a little bit which technology we're looking at. If we look at polymer additive manufacturing, indeed, often this technology is very fast and it can help to have availability faster. And I would say we even have a bit of distributed additive manufacturing here, because essentially any MRO that on the world has some 3D printers and could consider them for certain parts where the technology is applicable, right? But then when we talk about more critical parts and metal parts, it's really not so much distributed, and the tendency is rather the opposite, maybe linked a bit to the factory of the future, because the factory of the future is not something that you build at every airport to be able to have your spare parts, right? It's a highly sophisticated system of different processes, right? And metal additive manufacturing on its own is actually already a very sophisticated process chain, because it's not only the printer, you have a lot of pre and post processing. It's very complex, you need to manage it. And what I haven't even said is, but what I had in the first point actually is, for us, safety always comes first. We are in a heavily regulated environment, and any shop that you want to use for spare parts, for example, for distributed manufacturing, you also need to qualify and certify it, right? So every time you want to duplicate a shop, it will also bring you additional effort to put it in place, right? So especially in Metal AM, we're rather really on the opposite side. We're trying to combine volume. We're trying to build more economies of scale, to go more in this direction of the factory of the future. Where we have optimization, where we have flexibility, agility. So it's more central than decentral, actually, when we talk about Metal AM.
Just maybe one detail I want to add is, in the world of sustainment, and especially when you have system down, and by system I mean aircraft down. In our world, we don't carry people. Airbus does carry people, obviously. So there's a different level of requirements there. But at the end of the day, it's a risk management question. And so for the defense folks, when they are in theater, which is like in service or in action, the question is, what is the risk of me using a 3D printer to make a bridge part, a temporary part, to get myself back online for the time that I need to get the real part back in, right? And so now we're not talking about a permanent solution. There's a lot of that distributed manufacturing that is actually used as for transition solutions. And then it's a matter of risk management. How risky is it to print the part compared to getting the parts from the factory that is actually a machine part, right? In the case of metal, that would be a big question. Polymer typically are associated with lower risk type of part, and so it typically helps better and more than metal. And I agree with Aki there. But it's all about risk management, and then what is the reward of getting that system back on compared to the risk you're going to take by going fast and getting that printer online.
I want to jump on that, Steve, and you know, when you are in discussion with different executives, for instance, how is the conversation around distributed AM going on? Are they pushing for it, or do they still need to be convinced?
No, I mean, if there's one, I would say one entity or a group of people that are pushing for distributed manufacturing, the concept of having printers near the action, and we'll call it in theater, is the Department of Defense, Department of War. Why? Because they have all these transition problems. So the Army, the Navy, the Air Force, they have a situation where they cannot wait for the part. Let's say the part is days away, or they're like weeks away. They cannot wait for that, and then that's the first thing that they are focusing on is sustainment and transition solution. From a longer term perspective, the manufacturing of new systems like aircrafts and other systems happens at the factory, the proper factory, where you have everything, you have the time, and you have the whole process covered.
Yeah, all right. Well, Halker, if you imagine a future where AM-based repair and part production is distributed across MRO facilities, what does the digital thread need to look like to make that trustworthy and auditable?
So Well, if I imagine that I want really distributed manufacturing, if we say this risk assessment, that is already a challenge for General Atomics on unmanned aircraft that are also smaller than ours. And if I really want to do that, even on our much larger aircraft with hundreds of people on it, well, then of course the digital thread plays a role, but the digital thread already plays a role today. It's actually not really at all specific to additive manufacturing. We buy 80% of the value creation for our aircraft are parts and systems that we buy. So all of these suppliers and shops around the whole planet that are supplying parts into Airbus are linked digitally to our production network, right? They receive CAD data, specifications, etc., and all of this needs to be controlled and could, if it wouldn't be safe today, it could be manipulated, right? So this is not so much different. The topic becomes really interesting then if I imagine that I would have is an additive manufacturing machine, a 3D printer that is so automated, so controlled, that I could give it to anyone on the world who has no idea about the technology, right? And this person can just buy a license and a CAD file to print the part, and it comes out of the printer and it's ready. That's not the reality of additive manufacturing at all. Even for polymer, where it's quite simple, we need still trained people. It always starts with how you store the raw material, right? If you have humidity in your polymer raw material, you will get faulty parts. And someone who's not trained in how to store his raw material will do this mistake eventually. So we're not there yet, but I can assure you we are very well managing our digital thread, and
yes,
the CNC machined part, right? That's not so far in the end. It's also CAD data. It also goes on an automated machine.
Yeah,
yes, and we have to control that. So we do manage that piece.
Well, let's talk a little bit about certification, which is still the ultimate bottleneck, that we see across, well, let's say all areas of aerospace and also defense applications. How are you addressing that in your qualification frameworks? And do you think the industry is converging towards shared standards, or is everyone still building their own approach? And I would like to start with Steve on this one.
So, well, there's a few questions in there. So I think we are now in a situation, much better situation we were 10 years ago when it comes to standardization of processes and just the maturation overall of the technology and processes associated with it. So what that translates to is back when we started with additive in production, we had not a whole lot of frame of reference beside other people that have been doing it before. So we've favored a lot of partnership to accelerate us. But at the end of the day, we had to make our own specification. We had to do a lot of testing internally and so on. So and kind of do our own diligence because there was not available to us. Nowadays, there is more of these standards that are emerging for different technologies and different materials, additive technologies and materials, which is an accelerator for newcomers or even like existing users like me, for example, when I'm interested in a new material and suddenly the qualification is done or I have a spec that I can refer to, it accelerates me on the application side. So you ask about the approach. So our approach is qualifying the process and the part families as opposed to doing a part qualification. What does that mean, right? So part qualification is typically where a lot of people did that or are still doing it, and it's part by part basis. So I'm going to optimize my process parameter. I'm going to optimize my materials and all the testing regimen and things like that. I'm going to test a bunch of special coupons associated with that application. When you have enough of that part to print, you can afford to do all this work and spend all this money. In a case where in our company, we have a lot of different variants, but not a lot of volume of each of those variants. So we call this I mix low volume type of situation at our aircraft level. So everybody wants a special aircraft. And so what that means is that we have different parts a lot of time. And I don't have the money and time to go qualify each part by testing each parts. So I have to qualify a process, a set of materials. I have to spend my money and time on those materials where I cannot afford to have 25 different types of plastics and metals qualified to do everything under the sun. So so it's really material qualification, installation qualification, operational qualification, and then a part of it is like part specific adjustment and qualification. What that means, I have to have printer to printer qualification. I have to have my procedures all qualified and things like that. But once it's all qualified, I can then put more application within that framework, and then it multiplies the number of parts that I can put on my aircraft safely. So that's kind of the framework that we're adopting on our side, and it means a lot of diligence and lots of engineering work. But once it's done within a certain framework, I can put application in that box. If I want to put new application, I have to increase the size of the box, and I do more testing to increase the size of that framework.
Okay, understood. What about you, Hauke? What are your thoughts?
Can you repeat the initial question?
Yeah, so I was actually talking about the certification as a persistent challenge, you know, across different supply chain scenarios. Yeah.
Right. Because I had also thought about the end of Steve's answer, but maybe I come back to that. So when we started, we were in the middle of the hype, right? So everyone wanted to do it on its own. Everyone thought we need to be the fastest. We need to do this. So I think the whole AM industry and all the OEMs who went for it spend a huge amount of money on coupons. And to a certain extent, I would say that's good, right? Because again, for Airbus, we carry a lot of responsibility. We take this serious. So I can say we learned a lot. And we are managing our AM processes in a way that it's for sure very, very safe. So here I have really, really high confidence. But it costs a lot of money, and it makes AM industrialization a big challenge. So standardization is super important, I believe. And I see also high responsibility in the machine manufacturers to play along here, because essentially it's not added value if every user of additive manufacturing repeats the same kind of qualification and repeats this printing the same kind of test coupons. And this must have happened thousands of times around the planet to do the same or very similar test programs in the end of the day. So I think we made a lot of progress. We have some functions, some institutions that really push for that. I think the ASTM is certainly a leader who's facilitating a lot of standardization, and that's good. And since we started, there's a lot more maturity in the AM industry. So
yes.
They're easier to qualify than they were 10 years ago. But still, we're also not at all at the end of it. And I think this relates a little bit to what Steve was explaining. We're still qualifying a lot. Every new machine, we qualify every new application. We do maybe a part qualification. So there still is a lot of coupon printing ongoing. If as an industry, we could somehow combine this, simplify it, do it on a central site rather than repeating it for every user, that would make it better. But it's not an easy task, because again, in commercial aviation, we have the aviation authorities. We are responsible. We have to carry the burden of providing the evidence. So if we do this with a standardization body, with the central organization, it has to live up to our standards. We need full access, and it remains a bit a complicated challenge. But then again, if the machine OEMs and certain standardization bodies have already done a good job before, it's much easier to do this last step on our side.
Well, Hauker, what is one certification practice in the civil world, or let's say the commercial, aviation space, that you believe defense should adopt? And one thing defense does better than civil could learn from?
Yeah. I don't know how much we can adopt each other's certification processes, right? These are the things that are the most static in the end.
Yes.
But we have two approaches in commercial, and I think these two approaches might exist also. I think it exists in the defense and space industry, and there's a different extent of it. So we did start with part qualification, and we go much more for process, what we call process qualification today. And this can bring down the cost. That comes again with a trade-off, because what process qualification means is that we have tighter control on the process, but then less testing on part level.
Yes.
So for each new part, this means less cost to implement it, less cost to qualify it. But it removes also variability in the system, right? And I think there's even a question about that. One, I could answer it.
Well, I will first like to hear Steve on that, because I don't know, Steve, do you think that there's nothing we can learn from civil aviation?
Process qualification is, I think, something that is good, and that probably commercial aviation is focusing a bit more.
Yes.
Trade-off, right?
Yeah, I mean, I have visibility on what this civilian aerospace type of requirements requires, and
yes.
the type of certification requirements are. Obviously, I'm more on the defense side. I think we have more in common than we have difference, quite frankly, because coupons are coupons, and testing are standards, and processes. We're dealing with the same machines, the same type of materials, and things like that. So there's a lot of commonality in what we do. I think one of the major difference I would say between defense and civilian certification is that in defense, everybody has a different opinion of what certification means. So, and the truth is true. So we don't have a good old FAA or a standing organization that controls the requirements for certification for aircrafts, civilian air. We don't have the equivalent. We have military standards in defense, but for additive, those military standards don't exist. And then then every platform owners like we are needs to provide our certification package, and then somebody has an opinion on the other side, which is on the defense side, the customer side, and says, well, is that enough? We have a committee, we have airworthiness committee. They're very, very knowledgeable about what their platforms requires, but they have an opinion. And it's based on what their requirements are and what they're willing to accept in terms of diligence package. So I think having a centralized way of requirements would simplify and accelerate us. Similarly as the civilian aerospace. So that's one piece of opinion. But
okay, good. Well, I think we have more questions on certification and qualification. And I would like us to take it before moving forward, if you don't mind. Let's say the first one is for Hauker on process. Well, I think you already, gave a part of response to these questions, but I will still read it. Process lock-in is a real barrier in civil certification. A part qualified on a 2-laser system can require requalification on a 4-laser system, even with identical materials and geometry. So do you think it's, the challenge here is socially embedded in how regulators think about the qualification? Hauke? That's one question for you.
Yeah, it's a very good question, because it's a big challenge that we have today. And it relates to why I try to explain that we are not, especially in metal additive manufacturing, we're not going for decentral manufacturing, but for central manufacturing, because of these challenges, because of the evolution that we have in the technology from so small 250 cube machines, single lasers, or even 2 lasers, towards bigger machines where we can lower the cost of the printing. And in the end, that's even just 30% or half of the final cost. There's also the post-processing, and also here we need automation and line balancing and so on. So we need volume to do those kind of steps, and these steps are big, and they remain big for the moment. Every time we go to a new machine that we have not used before, so we use a lot of 4-laser machines, but the next step is in front of us, going from a 4-laser machine to a 6 or 12-laser, whatever, requires a requalification. And you can be locked in because all of this requires CapEx. And then if you plan an amortization of about 10 years, which I don't know, you shouldn't have done that on this kind of market, I guess, but it's not easy to get your money back, right? Especially if maybe you were a bit ambitious in the beginning. So it relates then to solve this question. We come back to the point of standardization bodies. If you leave it to every single user to mature those machines, because often when they come to the market, they're not mature yet. They're not industrially mature. Sometimes they're not technically mature, so they cannot be qualified straight away. But even if they could be, and you don't have any kind of development phase, doing this on your own, it just brings a lot of investment that you have to do. So I can just advise the machine OEMs to make it easier for their customers to adopt those much larger, more expensive, more complicated machines, to work with standardization organization, build consortia. Why also with us? Why not? To ease this entry burden, to avoid some of the customers being locked in on older machines.
Yeah. Steve, there's one question for you on, the U.S. National Defense Authorization Act, which was signed in late 2025 in December, I think. And given the fact that it introduces explicit requirements around sovereignty, data security, etc., how is GA preparing for that? And do you see it as a burden or as something that was already implicit in how you operate?
Yeah, it's a very popular topic within the additive community, and especially in the defense community for additive. The reality is, I don't understand the big deal. And this might be me, but we are already operating under very strong cybersecurity protocols for any data that we exchange, for internal networking and external networking. So if we do exchange data package, whether or not it's with a machine or with another individuals, we have all these protocols that we have to operate. And this has nothing to do with additive manufacturing. It has to do with everything that we do.
Yeah.
So securing a machine as well comes with a certain amount of diligence. Obviously, you don't allow machines to be plugged into the clouds, and you don't allow the OEMs to plug into your to your machines and do things. So there are things that we do to secure our equipment and manufacturing process in the data package, but it is already built into our DNA in the way we do work. And I can't speak for Airbus, but I'm suspecting it's very much the same. So I don't see the big deal. It is something that we need to do, but because additive is just another tool in the toolbox, you apply similar type of protocols as you have for your entire toolbox. Now, are they foolproof? Are they quantum computer proof? That's a different question, but it's not additive specific. That question is not fundamentally additive related in my view. But I'm not sure if Anke has a different perspective on that.
No, I think I gave exactly the same answer earlier on the question about the digital thread for distributed manufacturing. I fully agree with you, Steve. It's not specific, and we already apply high scrutiny on cybersecurity.
Well, I understand it's more, of a cybersecurity question, but the fact that we have specific software companies working on specific cybersecurity solutions to, facilitate or help part manufacturers, do their work when it comes to supply chain disruptions. I feel like this topic still has, its place, on the table. So, I mean, that's my take, but I don't have the technical experience to back my words up. But I still feel like it's a topic that should be discussed.
Sorry, I didn't mean to belittle the concerns in the question.
Okay.
My comment was more towards, it's not really a new thing. It's not necessarily an additive thing, but we definitely need to talk about it. And additive, being the new kids on the block in terms of manufacturing technology, it has an intrinsic digital component of the data management and the data component to it. And so it resurfaces all of these questions every time we talk about additive, but it's not fundamentally that. Now, the one thing that it does have an impact is those software OEMs that loves the whole cloud base and the whole subscription base and the whole, like, I'm going to upgrade your software every other minute because I want to. Those OEMs needs to understand that this is not going to be compliant and this is not going to be working for people that really want to do real thing with their solution. The great solution, but they have to think about their solution in the context of securing the data package. And it's not going to be, I'm never going to expose my company, my products to some company that has a cybersecurity protocol that have no visibility into. So that's kind of the reality of life. But yeah, it is a very important discussion. It is a very important topic. I didn't mean to belittle it, but it's not additive specific to me.
Yeah, understood. Well, we still have time for more questions. We still have 15 minutes left. One question that I think is for you, Hauker. How do you handle a situation where one business unit has qualified a material process combination that another business unit could use, but again, the regulatory environment or customer requirements make that transfer impossible without starting the qualification process again?
Yeah. So it's a fair question because very often it's not one perfect transfer possible.
Yes.
But we do that still for the 90% that are transferable, and this is the case. And I think this relates again to the question of standardization bodies. So everyone has a little bit its own specifics, and everyone has to carry its own responsibility.
Yes.
But there's probably 80-90% of the kind of testing that we do that we could share, right? And
yes,
and Airbus, and it would be really frustrating if we didn't do that. But in between our internal divisions, we really try these days harder than maybe in the far past. But we really try to share as much of our material specifications and our qualifications as we can. And this is quite successful. So we have some materials that have been qualified earlier in commercial aviation that we can quite with very little effort copy to helicopters and defense and space. And we have some other materials that are really lightweight, product value driven, that have been earlier qualified, implemented in defense and space, where we can set on this. And we need still to do a little bit of extra.
Yes.
But the way to the final goal is already shorter. So
I would be happy if you could provide like just a concrete example so that we can really picture the scenario, if that's possible, if it's not confidential.
So no, I think I can talk about it. We have published examples. So one alloy where we have done this transfers, for example, on Inconel, where we have since years parts certified in serial production in Airbus commercial. Part of it very often is competitive versus casting. So even on the existing serial parts and commercial aircraft, we can change them to additive manufacturing. This material specification, we are also using it for other divisions today. And the other way around, there's the scalm alloy material, I think, which is very well known. Which we have not focused much 10 years ago in commercial aircraft, but we had much higher focus in defense and space business. where we are able to set on this experience and transition it also in commercial aircraft. Because like I said earlier, we're getting closer to also a new program in commercial aircrafts.
Yes.
And on a new program, we have a much higher benefit on this kind of high performance alloys than when we want to replace parts that have been designed with AS7 normal casting alloys, right? And where we have essentially to keep most of the same geometry alive, and then switching to a high performance alloy doesn't bring you that much benefit.
Understood. Thanks, Hauke. There's one question for you in the Q&A chat, Steve, from Alison. Yeah. Oh, sorry. So, from my vantage point, I often see people have excellent written procedures and process documentation, but do not follow them in daily life. Basically, the broken flow down and flow up situation. How are you dealing with that, especially when you end up relying on, well, tribal knowledge and smart people to run your AM factory? Thank you, Alison Park from NIER.
Hey, Alison, how are you doing? Thanks for placing a nice little question here. All right. Okay. What's the human? So it all comes down to human dependencies on your quality process. Additive manufacturing is just yet another manufacturing process. The caveat to that statement is that it is a foundry and a machine shop. Well, so if I think about, you would start with a raw material block and then you would transform it to a final part into, let's say, in a machine shop. You would have those two separate, and you would have process control on the foundry and the raw material side, and you would have process control and people and process and training on the machining side. The combine into additive makes that we have more variable to control. That's pretty much the basics of it. The question that Alison is asking is how many of those variables depend on people to be consistent and to be high quality. The answer to that is there's a good series of that. Those steps, for example, conditioning materials before I print my FDM parts ultim, right? So I need to make sure that I test my materials right. I need to do my calibrations, and I need to do my coupons and things like that. So there's process that depends on the humans doing their job right. And for that, we have constant training programs and refreshers, and we have redundancies also in the skills that we run the factory. So it's not just one person, but each of the techs are helping each other to make sure that we are par with the same high standard. But fundamentally, there's a lot of checks after we're done with our work. So we don't necessarily trust the humans completely, in a sense that we have machine to trust and we have human to trust. And at the end, we do metrology inspection component, which is composed like over 40% of our cost on the total additive cost. And that's at the moment, that's the cost of trust, right? If you will. I think moving forward, we are now implementing AI solutions to start assimilating more data from the machines so that we can actually build that trust into the data that are acquired from the machine. And that's going to be lowering that quality, that quality of the cost of trust from a metrology and quality standpoint. So I'm not sure if that's what Alison was alluding to, but there's a series of training refreshers. There's mentorships that we do on the human side. There's always checks and balances that every operation needs to be capturing data that proves that you actually done your diligence. So we try to control that as much as possible when the human is in the mix of that variable that we need to control.
Thank you so much, Steve. Well, Steve, have you had a case where additive manufacturing enabled a good enough today interim solution for the field that you later on had to, well, drastically change again?
I can't deny that we've done that. However, I would say the good enough sometimes gets you in trouble. Depending, and I'll go back to my statement earlier, is that it's all about risk management. So if you think about our aircrafts, we build aircrafts. We don't build 50 aircraft at once. We build the first one, then we learn something, we build the next one differently, and then we do this iteratively. And it's the same for us. And then we get to a point of production, and by that time we have a lot of confidence in everything that goes into production. In the early stage of that process, when we are testing and so on, we tend to go, the time is more important than the cost, right? So we would be in these cases be more prone to use fast tooling with additive manufacturing that will not necessarily last forever, but then it will be good enough for those parts. Same thing for I may want to cut corners and then not do a composite part, so I'm going to print it in polymer just to test the aerodynamics of that part. But again, I'm not going to risk the safety of the flight. It will depend on the risk posture for what I'm trying to do, and I'm going to use additive wisely for that. But one way to mitigate those risks for the good enough solution is to use a qualified process no matter what. The difference so I don't fundamentally use a different process for a prototype part compared to a recurring production part. The only difference is the amount of coupons I'm going to have to go do, and then the amount of QA I'm going to have to throw at that part, and so on. So I'm going to go to the essential that is associated with the risk posture of the application at that stage. And that is very much like a case-by-case basis. In production, you don't want to do that because you want to have that consistency, that data package that guarantees that plane A is the same as plane B, is the same as plane C. So it is completely different kind of use case, and it's a risk posture based, case-by-case basis.
Thank you, Steve. We have less than 5 minutes before the end of the panel, and I really want to ask this one. Do you have any questions for one another? Alker, do you have any questions for Steve? And then,
okay. Oh no.
Yeah, I have one actually, Steve. Just when we were waiting for the panel to start, I told you that I was impressed by some of the case studies that you have published. Where you basically printing the whole fuselage of a drone, even though it's small, relatively small drone. So these kind of concepts have, of course, been in the minds of engineers already many years ago in Airbus, right? But our fuselages are giant in comparison, right? So we talk about many meters. But I will still want to ask you the question. So maybe focusing on powder bed fusion, how far do you think will it go? How much of a drone, maybe let's say a Reaper drone, I think if it's that on the picture behind you, you think you could print if you were to design a new product and you want to optimize it and want to try to integrate everything? How far do you think you could go?
Good question. Just anecdotally, when I started here, when I started teaching or talking about additive, the first question I would get is, when can I print my plane, right? And then my first question, my answer was, don't get too excited. I'm going to start with parts on your aircraft. So for the plane right behind me, this is called the Sky Guardian. So the MQ-9B, which is a civilian certified aircraft, definitely much smaller than Airbus plane, but it is still for the US. It's 80 feet wingspan, so it's quite a few meters wingspan. It's quite sizable. So for us, we're less than 1% additive content on that aircraft, and it's mainly at the part level. So a bunch of the hundreds of different part numbers on that aircraft. So it's definitely not printing the plane. So you're now fast forward several years. The most meaningful and important metric that we now follow when we design a new aircraft, whether or not it's a large one or a smaller one, and we obviously learned it on the smaller one and then started increasing it to several meters long plane now, where we print close to 60 to 80% portion of the airframe structure using additive manufacturing. it is a part count reduction. So if I do think about the aircraft as 20,000 parts, I'm going to say, well, does it make sense to print 20,000 parts to put it together? The answer is no, absolutely no, because additive is too expensive. But if I do reduce my part count by 50%, by 60%, 80%, 90%, now you're starting to think about a very, very complex structure, and now additive starts making sense. So it will be expensive, but in the aggregate, it will be so much cheaper. And so to answer your question specifically, on the small aircraft and a medium-sized aircraft, maybe that would be like one size before that. We are growing into the 60 to 75% of the airframe being printed. And then it's all a matter of how do I holistically design the aircraft for the function? And then I ask the question, how big can I print my nodes? And then the answer is not always one technology, not always one additive technology. And it actually is multiple types of materials and additive and non-additive technology that will answer the question. But fundamentally, if you do start with that functional integration of parts, it leads unavoidably to additive manufacturing. And then you start looking for much larger additive manufacturing solutions, which does include laser powder bed fusion, but also the ED side, and then large scale composite.
So do you do that? And even if not the Sky Guardian, then on the Reaper, which I think is the one above.
Yeah,
like fuselage in AM.
Yeah. So what Katie mentioned earlier is, it's not worth my pain to go try to redesign this aircraft or this aircraft, right? Those are done deal. The customers, the platforms, everybody, don't touch my stuff.
Yes.
So it's really the next generation aircraft that are then now applying those design approach and manufacturing approach that we're talking about.
Okay, good. One question. Do you have one question for Hauke, Steve?
Yeah. From our side, we valued partnership very early on in our additive journey, because we recognize that what I care about and what's IP sensitive is this, not so much the coupons and the materials and so on. So getting there as fast as possible from a qualification framework, specification, allowables, and all those type of things have been really in the realm of partnership for us, and try to joint effort. And so how much of that mindset or philosophy exists at Airbus, or is it still very much like additive is IP for us and we don't share, we don't play with others and things like that? What's the mindset on the additive front from your perspective?
Yeah. So actually, I think Airbus is a company that's partnering quite a lot normally on additive. Surprisingly, in the first years, we did not do so much partnering, and we really thought we can do a lot on our own. We wanted to be fast. We thought it's IP to qualify the machine faster than everyone else. And I think we learned that on additive manufacturing, we have to partner, and especially with the machine OEMs, because all the machines that we bought 10 years ago, none of them were qualification ready. So on additive, we are not developing our own AM machines, our own printers, right? So we have to partner, and we can be much more efficient when we do that. But I really wish also the machine OEMs to come our way as well, right? And some of them do. So then it's great if they understand our requirements. Some of them apply very similar requirements, right? So then this makes big steps forward. We still need multiple partners also, right? So we wish all of them to go this way. But yeah, we have to partner. We have to partner, and we rely heavily on the machine OEMs. And
I guess that was a self-serving question for me, because I have a project I want to talk to you about.
Okay. and then maybe this is why I come in to say that I will share, contact details later on after the conversation. But we are here at the end of the panel, so Thank you so much for sharing your thoughts, your insights with us, and I hope for the audience it was a very useful conversation. If you have any questions, that you would like Steve or Harker to answer, please feel free to share them with us by email. We will reach out to them and answer the questions before the recording goes live on our online media. Thank you so much for staying with us until the end of this conversation, and stay tuned and stay safe wherever you are in the world. Thank you, Steve, and thank you, Harker.
Thank you,
have a great evening. Have a great day from California.
Nice.
Yeah. Bye.